Hello everyone, my name is Achintya Sharma.
And I am Arindadwal,
We are Team Unsupervised Miners from NIT Jalandhar.
and this is our submission for the Machine Learning and Deep Learning Premier League organized by TSM Tamil Nadu.
So the video is structured as follows. First comes the research, the design and the dataset creation using organic data.
And then the code implementation, including pre-processing, the feature engineering, and then various tree-based models, and then optimizing their model weights, and then the Monte Carlo simulation, which is widely used for sports predictions in league table format.
And then the final conclusion of our work along with the model deployment. So now let's move on with the video. So now let's move with the dataset. Now this is the primary dataset that we use to train our model on. Now there are a few things that I would like to highlight here that are important. First being is that we took the data from 2021 to 2025. The reason being because that represents the current form factor and the current team roster. Now along with this, we supplemented this dataset with another dataset to add pitch related info, which according to our research was important for our model to be trained on. Now along with this, we also added some new features such as home advantage and toss decision advantage. Along with that, these are all the pitch related info. Now, so in total we created 3 datasets. The first being the training dataset from 2021 to 2024. The next being the testing dataset, which included all the 2025 matches that were already completed, and then the supplementary dataset, which always was of the remaining matches that we used to make our predictions for the final winner. So let's move on with the code implementation.
Okay, so now let's walk through the code that we wrote. First of all, we imported the important libraries, NumPy and Pandas for data handling and numerical operations. I imported scikit-learn for pre-processing, model training, and evaluation. And then comes the pillar stones of our project: XGBoost, LightGBM, and CatBoost classifiers, which are tree-based, and these were like A.B. de Villiers, Virat Kohli, and Chris Gale in our project. I also imported a random forest classifier too. And then I used a warning suppression for because so much rubbish output was coming due to model training. Afterwards, our system begins with 3 datasets, which we created organically on our own from normal data. First one is historical IPL data from last 4 years, the current 2025 completed matches, and then the remaining matches to be predicted. We used a robust date parser, which handles mixed date formats, which is crucial because cricket data comes from various sources with inconsistent formatting. The key insight here is that consistent data is the foundation of accurate predictions. Garbage in, garbage out. So we spend significant effort ensuring data quality in our datasets while preparing them. Now comes the main wizardry of our project, the feature engineering pipeline. First comes the home advantage. It identifies which team is playing at home and creates binary indicators for home and away status. Cricket teams generally perform better at familiar venues because they have their fan support. And then the toss strategy features. It calculates who won the toss and what they decided. This thing we wrote a function on our own. This doesn't just check that who won the toss and gives them positive points. What this does is, if a particular team won the toss and then they took the right decision, if the pitch is batting friendly, they took batting, then that is considered positive. Now comes the head-to-head statistics. It calculates historical win rates between specific team pairs because some teams have they perform consistently better against certain opponents because there are rivalries like RCB KKR, RCB CSK, MI CSK. So it creates a comprehensive lookup table for all team combinations. Now comes the recent form. Uh, Here, for past 5 matches, yes, in the completed matches datasets for past 5 matches, it calculates the team's performance, and then the winning streaks are really important because momentum is a thing that can affect a lot and of the future performance. And it follows dynamic calculation based on the match date. And afterwards, we did team encoding because Machine learning algorithms can process only numerical data, so we converted team names to numerical values. Afterwards, the main firepower comes the 4 classifiers we used. First comes the XGBP processor, and afterwards the random forest. It is great at handling complex interactions between features. And then the XGBoost, it was chef's kiss. This was leading from the front with the most accuracy. So we gave most depth and weight to this XGB model. It is excellent gradient boosting performance with fast training. And LightGBM, it is efficient and accurate and handles categorical features quite well. And CatBoost. CatBoost was specifically designed for categorical data, and it is robust to overfitting because we don't want it to leak, and as that's cheating. So now comes the hyperparameter optimization. Each model undergoes grid search to find optimal parameters, the number of estimators, tree depth, and learning rates. The cross validation ensures we don't overfit to training data. The stratified k-fold maintains class balance across validation scripts. And the voting strategy was this was really great. We used weighted voting. Like each model's weight is based on its individual accuracy. So soft voting uses probability predictions, not just class labels. This ensemble approach outperforms any single model alone. The training strategy we used was to use all the data before 2025 for training, then testing on 2025 matches to validate the performance, and then using the concatenated data of last 4 years and the completed matches to predict the remaining matches of IPL 2025. Now comes the prediction pipeline. For each remaining match, our system applies all feature engineering transformations. It handles new team encoding safely, and it generates probability scores for all possible winners. It extracts team-specific probabilities for 2 competing teams and selects the winner based on higher probability.
3, 2, 1, go. So now comes the model deployment. So to deploy a model, we use an AI tool called Vercel, which is specifically designed for web development. Since 2025 is the age of AI, and if you're not using AI tools, then what's the point? So the website is designed in a way that it is user-friendly for a stakeholder who just wants to know the predictions, as well as it includes all the necessary technicalities to check which models were used. So the first page includes all the individual models that were ensembled along with the input features. The second page includes all the accuracy scores of our models, and then the prediction section where you choose a match that was not conducted, which is the future matches of 2025, and then it predicts the winner. So it fetches the results from our model and then shows you the winner with the winner percentage as well. So Gujarat Titans is the winner of this match, and then the champion. So since our model predicted Gujarat Titans to be the champion, so when you press reveal champions, Gujarat Titan comes out with an accuracy score as well. So this was all in a nutshell of how we deployed the website.
Now the funny thing that happened with our prediction was RCB won the IPL, and in our model it wasn't even in top 4. Our model showed that GT won the IPL, but this is direct consequence of the data set we took. We took last 4 years in which RCB performed really trash, and GT was the king of the IPL in last 4 years. So some few things we also wanted to do, like Twitter scraping. We wanted to scrape data from reputed Twitter handles and use their prediction as weight in our model. Also, we wanted to use fan engagement on Twitter. Like if it's positive, then it will be positive in our model, and so on.
Another feature we wanted to implement was an aura feature. So what this basically means is in a dynamic match, there are multiple things that can happen. When a new batsman comes in and is out in the first over, then it gives a negative aura towards the batsman team and a positive aura for the bowling team. Similarly, if a batsman comes in and scores multiple sixes, then it's a great aura boost for the batting team. Now this actually maps the dynamic nature of sports. So we tried to implement this, but because the data set was very large for ball by ball data, and we didn't have the computational resources, so we were unable to implement this as well. So thank you, ladies and gentlemen. I hope you enjoyed the video, and this officially marks the end of our submission. Thank you so much.